The histories of soap. The first soap and detergent makers used plant ashes to produce alkalis to wash with. Babylonians were the first ones to master the art of soap making in 2800 BC using fats boiled with ashes. The Eber Papyrus, Egypt, in 1550 BC, reveals that ancient Egyptians mixed animals and vegetable oils with alkaline salts to produce a soap-like substance. Additionally, the Celts made their soaps from animal fats and plants ashes that they named Sipo, from which the word soap is derived.
Back then, plant byproducts and animal and vegetable oils were the main ingredients of soap. The price of soap was reduced in 1791 when Frenchman Leblanc discovered a chemical process that allowed soap to be sold for much less money. Another Frenchman later identified relationships between glycerin, fats, and acid, which marked the beginning of modern soap making. With the 1800 discovery of another method of making soap ingredients, soap became even less expensive. Since that time, there have been no major discoveries, and the same processes are used for the soap making we use today.
In the 1930s, commercially available routes for creating fatty alcohols brought the rise of several detergent brands intended for industrial use, like Tide. After the end of the Second World War, many American effort factories were converted from civilian use, and one of the most widely available products was tetrapropylene, which is used in the creation of home detergents. One of the most popular detergents of the time were alkali benzene sulfonates, but is but its inability to be biodegradable forced the manufacturers to create a linear form of it. Aromatic gels, ultra fabric softeners, super concentrated powders, and liquid detergents were all invented in the 1990s. What are soaps? Soaps are water soluble sodium or potassium salts of fatty acids. They are composed of two parts. The first part is a carboxylic acid group consisting of one hydrogen, two oxygen, and one carbon atom, plus a hydrocarbon chain that is attached to it. Additionally, the second part is an alkali, a soluble salt of an alkaline metal like sodium or potassium. Alkalis. They are bases that neutralize an acid. They are effective in removing dirt and stains from fabric without excessive rubbing. They are produced by running electricity through salt water to produce sodium hydroxide and potassium hydroxide. They are soluble salts of an alkaline metal, like potassium or sodium, which are good grease removers.
In laundry detergent, surfactants are a major component. Their role is to break up stains and suspend the dirt in the water to prevent redeposition of dirt onto the surface. In a way, they work like an oil vinegar dressing. They do not mix unless shaken vigorously in the bottle, and then they separate almost immediately after. The same is true when washing clothes. Surfactants shake up the soil, which normally does not dissolve in water, making it dispersible as the water molecules surround it. Surfactants themselves can be very diverse. In anionic surfactants, the head of the molecule has a negative charge, making it good for removing stains with minerals like magnesium and calcium, which are positive. Non-ionic surfactants have no charge and are typically found alongside anionic ones in detergent to boost cleaning action. Anionic surfactants are often listed as alkyl sulfates, alkyl ethoxylate sulfates, and soaps on the ingredient list of your detergent. Non-ionic surfactants are often listed as ethers of fatty alcohols on the label. Surfactants undergo a chemical process in order to clean our clothes. Step 1. The head of the molecule is hydrophilic while the tail is hydrophobic, thus attracted to the dirt and stains. Step 2. The detergent molecules meet grease on the clothes. The tails are drawn into the grease, but the heads still sit in the water. Step 3. The attractive forces between the head groups of the water are so strong that the grease is lifted away from the surface. Step 4. The blob of grease is then surrounded by detergent molecules and is broken into smaller pieces which are washed away by the water.
Surface tension and surfactants. Detergent molecules also help to make the washing process more effective by reducing the surface tension of the water. Surface tension is the tendency of fluid surfaces to shrink into the minimum surface area possible. The surfactant molecules break apart the surface tension of the water so that it spreads more openly. Remember that Each water molecule has one larger oxygen atom and two smaller hydrogen atoms. The hydrogen atom holds a slightly positive charge, making the water molecule polar. Like tiny magnets, the hydrogen atom attracts the oxygen atom from other water molecules, creating temporary hydrogen bonds within the water. Each water molecule experiences a pull from other water molecules from every direction. Water molecules at the surface do not have molecules above the surface to pull at them. These have more pull from the water below than the surface above, thus surface tension. Why is breaking surface tension so important? One example of surface tension is that when it rains, water drops into water droplets onto a window. It does not wet the glass uniformly due to surface tension. What is the surfactant's job? Well, the surfactant's job is to reduce that surface tension so water can spread all around the clothes and bring the detergent molecules attached around the stains to dissolve them. How it all works is that because one end of a surfactant is hydrophilic, it is attached to the water so the hydrophobic side of it cleans the stains in the clothes.
So how exactly do these chemicals come together in order to clean our clothes? Well, when you put your clothes in the washer, surfactants reduce the surface tension value of water and enhance its ability to stick to things. Water sticks to the clothes, and because of this, it's able to seep through fibers of dirty clothes and spread over a larger area. Keep in mind this is made possible due to the decrease in the surface tension. On one end, the detergent molecules attach themselves to the water molecules. On the other end, they attach themselves to the dirt present in unclean clothes. Lastly, the surfactants help spread water. Then they act on the grease by attaching themselves to it, and when this water is disposed of, it carries away all the dirt with it. Like dissolves like, the rule of solubility is very important to take into account in analyzing how detergent works. Soaps and detergents are quite unique molecules because they have the ability to dissolve in both polar and nonpolar solvents. Both are composed of long nonpolar hydrocarbon molecules with a polar or ionic end, thus they combine both polar and nonpolar characteristics into one. This allows the molecules to bond with both oil and water molecules at the same time, forming a connection between the oil and the surrounding water molecules. Soaps and detergents operate at the interface between the oil and the water and are known as surface active substances, or surfactants. With enough detergent or soap molecules present and agitation, the oil and dirt will wash off the clothes attached to the water via the detergent soap molecules. The agitation is important as detergent soap molecules stick out of the oil like paddles, which catch the current and wash away the oil and dirt with the water. You may not realize it, but washing your clothes is connected to the principle of the conservation of energy. If there's a certain amount of dirt in your clothes, you need to use a certain minimum amount of energy to remove it, which will be part of a chemical, part mechanical, and part thermal energy. Think of it like this. If you use less detergent, you'll need to use hotter water, aka more thermal energy, or wash for longer, which is more mechanical energy. Similarly, if you reduce the temperature of your wash or use less thermal energy, you'll generally need to add in more detergent for your wash.
Do you ever have a bad day where you cannot open or drink your soda correctly? Well, you see, that's the face right there. That's the face of, oh no, I just stained my very new sweater. How will I get it off? Well, lucky for you, Tide Pods got you covered. Well, you might be wondering, what are Tide Pods? Well, to simply put, Tide Pods are easy and effective ways to do laundry. You no longer need to buy softener and detergent separately because it comes all in one. These laundry packs are equipped with a 4-in-1 technology available in many scents. So whether you are trying to wash a week's worth of clothes in one go or trying to remove the impossible stain, Tide Pod does it all. Disclaimer, please keep at a child's reach and do not consume or eat Tide Pods because they contain very dangerous chemicals and can lead to serious side effects. So it is very simple to do. All you need to do is take your dirty clothes and put into the washer and then throw in 1 to 2 Tide Pods depending on how many you need. You set your washer and sit back and relax and watch as all your clothes become stain free. Here's the science behind how it all works.
Detergent and other cleaning molecules such as soap contain surfactants, which are substances that help with the mixing of other substances that typically do not mix well together, such as water and oil. While the clothes are in their rinse cycle, the detergent molecule has a tail that is attracted to fats and oils and stains, and has a head which is attracted to water. So the detergent molecule would surround the fat particle facing the tail inwards and turning the head to the outside. This eventually allows the stain to be captured and dissolves in the washer. In the Tide Pods used in this experiment, there are available surfactants which include alcohol ethoxylates, alkyl dimethylamine oxide, monoethanolamine citrate, and linear alkyl benzene sulfonate. They are all cleaning agents that help remove stains.
1 hour later. Now that your clothes is done washing, take it out and look at the cleaning power of Tide Pods. Wow, would you look at that? Here is a side-by-side comparison of before and after. If it's got to be clean, it's Tide Pods. As you can see here, this person had just finished cooking their eggs and still has a decent amount of oil left in the pan. Now you might be wondering, how do you clean off the oil from the pan? Well, the first step is to begin by washing the pan with water. Notice how you cannot remove the oil with the water alone. This is because water is a polar solvent while the oil is a nonpolar. Using the principles of like dissolve like, a polar molecule is unable to dissolve into a nonpolar one. They are only able to dissolve into each other if they have the same molecule. Although if you add soap, which contains surfactants similar to detergents, it helps break down the oil into the water and allows it to dissolve. This is due to their unique molecule. The head of the molecule is very attracted to water, while the end of the molecule is very attracted to grease. So this allows them to attach to both oil and water at the same time, mixing them together and cleaning the pan. Wow, would you look at how clean that pan is?